2011, 11 years ago, this question came out in Cambridge. So let's take a look. This glutamic acid. Glutamic acid has pKa values of the 3. Can you see? So they give you what I call the pKa values. They give you 3, means there must be 3 acidic group, no matter what, right? So we're going to find the 3 acidic group. So step 1 is that we need to assign the pKa values to the group. Remember that? Which I taught you the skills. And everyone? So that's step 1. After that, then we ask ourselves, what is the environment that amino acid is in, which is here. Second line, neutral pH. Okay? So we know the environment pH is pH equals to 7. All right, systematic, huh? So here we go. Now, what is pKa values? Let's recap. Remember, pKa values, we learn it in acid-base equilibrium. It has no meaning to us except that it's inversely related to Ka. It's the Ka that we are more interested, because Ka is directly related to the acidity of the weak acid group. Remember that? So pKa is the inverse of it. So I want you to think of Ka, not pKa. So it's the opposite. All right, so here we go in pink. 2.1, which is the lowest pKa, meaning the highest Ka. Everyone okay? So I hope you agree with me. This is the highest acidic, most acidic group. All right. 2.1 will be assigned to the most acidic group, and therefore, say the light blue color, 9.5, highest pKa means lowest Ka, lowest acidity, the least acidic. And the one 4.1 is right smack in the middle. So here we go. Let's assign it, right? It's everywhere. So of the group, which is the most acidic, remember, must identify what? Identify your alpha carbon out first. Where is the alpha carbon? I think this is your alpha carbon. Everyone okay? Why is this the alpha carbon? Because it has both the COOH and the NH2 directly attached to it. Everyone okay? So that must be alpha carbon. Always identify alpha carbon, and you got a chance. And then what did we learn? Which is in my notes. We learned that the alpha COOH, the COOH group attached to the alpha carbon, is the most acidic. So let's put the color in. Done. And I would like to write the value because I want to see it later. And what is the second group that is the most acidic? Is the other carboxyl functional group, right? Which means the orange is here. The least acidic group is the NH2 become NH3 group. So it's here. All right, least acidic is this one, which exists in the form of NH3+. Don't forget. Everyone okay? So by right, this is NH3+ in my mind. Always, remember? Always start with form number 1 when you have an amino acid question. So here's a positive charge here. And let me assign the value in 9.5. And the orange here is 4.1. Step by step in a systematic approach. Step 1, assign the pKa values to the groups. Done. Second step is now play with the pH value environment. So here we go. Revision in what color? Dark blue. All right, ladies and gentlemen, the general rule is like this. What is the general rule? It's all about the H plus there, right? The general rule is this. When the pH value is less than the pKa value of that specific acidic group, means what? pH means environment, okay? When the environment, so let me highlight in green, right? So this is the environment, the solution. When the environment pH is smaller than the pKa, it means in a way that it's more acidic than the group. Agree with me? It's a more H plus than the group, more acidic. So the environment got lots of H plus. You must agree with me. Therefore, in Singlish, it's called H plus on it. Also, in English, it's known as protonated. Am I okay? That's it. And the opposite must be true. If the pH value is much bigger than the pKa value, meaning A, you're more acidic than me, I am of higher pH, I'm more alkaline. So what? So you must give out, right? You are the acid, you must give me H plus. So the acidic group will be H plus of it. You throw away the H plus, i.e. in English, deprotonated. And everyone, so we're going to apply this. Ready? So let's color code it, all right? I have used a few colors, slow and steady. So here we go. Let's consider all three groups, the orange, the blue, and the pink. Okay, let's go it left to right. Okay, so the current environment is 7. All right. So ladies and gentlemen, 7 versus 4.1. I hope you agree with me. 7 is bigger than 4.1. Okay, everyone? 7 is more than 4.1. So where are we? 7 is here, is more than 4.1. Everyone okay? Take a look at my color code. Look at my pen. So H plus is off, is deprotonated for the orange group. Everyone okay? Makes sense to me? Which means this group will then be O2 minus, COO minus. Connected. Everyone okay? Aha. Then we'll highlight. Goodbye. Goodbye. I eliminated 2A. Let's go to the blue. The blue value is 9.5. 7 right now is what? 7 is smaller than 9.5. Make sense? Yeah. So where are we? We are here. So the H plus will be on. Make sense? Correct? Which means the group exists as per it is. I got the answer. Oh, the answer is B. But we have to verify in case I boo-boo. Then we go to the other side. Let's go to the pink. 7 is versus 2.1 is what? 7 is bigger than 2.1, right? 7 bigger than 2.1. 7 bigger than 2.1. H plus must go off. So the pink color here looks like CO2 minus. Answer is B indeed. I hope you agree with me, everyone. Option B. Done. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.